Cool, we're going to start our foldable notes on solving systems of equations. And in this first video, we're going to get our foldable labeled up with some definitions and then work through the graphing examples. So what you can do right now is make sure that your name is on your foldable. And then what I'm going to do is kind of get my foldable ready to work with and take notes. And I'm going to fold up the top part so I can have the graphing work available and flattened out with the staples. Hope your staples are all right. We stapled a lot of these together. The first thing that I want to do is put some definitions on the front of our foldable, the important things. You know, what exactly is a system? And a system of equations is a collection of equations with the same unknowns, or variables with the same variables. There's something on my table that's wiggling and making a noise. With the same variables. A collection of equations with the same variables. And there's notation that we'll see when we're dealing with systems. And a system of equations is gathered together with a bracket. And we'll see if you can open up your foldable and see an example of what that looks like. So then, if that's what a system is, and you've got a collection of equations, the question is what does it mean to solve it? You know, what's the work that we have to do and what's the purpose? If we're going to solve a system of equations, we want to find the values of the variables that satisfy the equations in the system at the same time. So to solve means to, I'm going to put this definition around the edge. What's this foldable all about? Solving a system means to find the values of the variables that make the equations, every equation in the system, true. Make the equations true. So what x, y's do they have in common? That's really what it is. So what x and y values do the equations within your system have in common? Because they're going to, well, we'll explore. We've got lots of things to find out about systems. But the first thing that I want to focus on is one method for solving systems. And we're just going to, actually, let's just call it method one. Number one, how do we find the solutions to a system? So I'm going to open up the graphing flat. Ooh. And as I'm adjusting everything here, I'll tell you what the graphing portion is going to have us do. Cool. There we go. Well, you know what, actually, I'm not going to tell you what it's going to do. What I'm going to do is ask you to take both of the equations in the system and graph both of the lines for these equations. I know they're lines. It says it's a linear system. So if I'm going to graph both of these equations, I'm interested in having it in our familiar y equals mx plus b form. So I can use the starting value, the b, or the y-intercept, to start plotting the points on my line. And then again, the slope is the m. And remember, we want to think about slope as rise over run. When we're on our graph, we want to think about slope as rise over run. You don't have to write that down if you're familiar and comfortable. Many of you should be. Many of you are. First thing I'm going to do is put these into slope-intercept form, which means I want to solve for y. And this is part of the reason we've been doing our work with literal equations, because we want to be able to manipulate these linear equations into a form that's easy for us to graph. If I'm going to, if I'm going to solve for y, the first thing I'm going to do is add x to both sides of my equation. Bring my equal sign down. I'm going to have 2y equal to 3 plus x. I'm comfortable with switching around my values, x and 3 over here. We'll talk about that more in a minute. I need y alone. I'm going to divide by 2, which means I'm going to divide every part of the equation by 2. And I'm going to get y equals 3/2 plus x over 2, which is 1/2 x. It's like 1x divided by 2. So 1/2 x. So we have a y-intercept of 3/2. Now, I'm kind of interested in finding out what this equation's slope and y-intercept are. I've got a slope of 1/2, and I've got a y-intercept of 3/2 here. I might want to use my grid lines as halves. Let me go to my second equation and solve that. So, well, not solve that, but solve it for y. Put it into y equals mx plus b. In this one, 2x plus y equals 4. Oh, this one's going to be a simple one, because the only undoing that I have to do is subtract 2x from both sides. And then at that point, I'll have y alone. All right, well, I was hoping that I didn't necessarily have to graph 3/2, but I think I can do a pretty decent job at it. So I'm going to pick up my lighter green marker that I used to solve this, and I'm going to plot my y-intercept, which is 3/2. 3/2 as a decimal is 1.5, or as a mixed number, 1.5. And then from there, my slope is 1/2, rise over run. So I'm just going to have to go up by half tick marks on my y-axis. So up one, yep, to the right 2. And I'm in the middle of these grid lines, but that's okay. So up 1, to the right 2. Up 1, to the right 2. Cool. I'm not going to get my straight edge out quite yet. I want to graph my other one. So my other one is y equals 4 minus 2x. And so what I'm going to do is start my graph at 4, the b value. The y-intercept is 4. 1, 2, 3, 4. And my slope is -2. So I'm going to think about it as -2 over 1. And I'm going to go down 2, 1, 2, to the right 1. Down 2, to the right 1. Down 2, to the right 1. Now I'm starting to see something here. Oh, I wish I would have grabbed a little ruler in order to graph. You know what? The edge of my phone case will work. Maybe not. Not the prettiest line, but that's okay. I'm going to put my arrows on too. Now, my grid lines, my lines with not a straight edge. I hope I remember to give you all rulers before we start taking these notes. I got to make a note to myself. What I'm seeing here is if my lines were actually perfect. Oops. There we go. These two equations would intersect or have the same x and y value right here at the point where they cross. So when we graph, the intersection point is where the solution is. And solving this one, I find that the solution, the value of the variable that is the same for both equations is, I go to the right one and up 2, the solution is 1, 2. I'm going to make that solution stand out. And again, your solution in graphing is the point of intersection of your two lines. So solution, point of intersection, specific to graphing. Cool. Now I'm going to go through the next one quite a bit quicker. Second example, quite a bit quicker. Try to wrap this up here. And you can, of course, take this home, and we'll take your foldable home and watch the video on your own. I'm going to start to graph this system, but first I need to solve for y in both of these cases. In this equation, the first thing that I'm going to do to solve for y is subtract x from both. Oh, no, I'm going to change my mind. Y is being subtracted. We've seen this before. I want it to be positive. I'm going to add y to both sides. I can get into y equals. My y is just going to be on the right-hand side. So 5 plus y. And then, oopsie, So I'm getting the y on the right just to keep it positive. And then I'm going to come through and I'm going to subtract 5 from both sides. And get x minus 5 equals y. So my y equals mx plus b. My m, my slope is going to be 1. This is going to start on the y-axis at -5, up 1, right 1, up 1, right 1. Slope is 1, so rise over run is 1 over 1. Cool. Next equation, my next one here, 3x plus y equals 3. I'm going to subtract 3x from both sides. Oh, I like this one too, pretty quick. And we're going to wind up with y equals 3 minus 3x. So I'm going to start this line at 3, and the slope is -3, so I'm going to go down 3 to the right 1, down 3 to the right 1, down 3 to the right 1. Cool, I can see where their solution is right now. Now something better than, there we go, a little bit better straight edge than my phone case. Cool. There's that line. I'm doing better with my graph of this one. Cool. The solution to this equation is pretty obvious to me now as well. The point of intersection, the solution to our system of equations, I should say, is 2 and -3. 2, -3. So I know you're going to be counting the moments until you get the video that outlines the rest of these foldable notes. Good luck.